Um, okay, so here told that the electric potential at the surface of an atomic nucleus, electric potential at the surface of an atomic nucleus, which is Z equal to 50 of radius. So this is the radius of the atomic nucleus. The atomic nucleus is 9 into 10 power minus 13 centimeter, or I can say it is 9 into 10 power minus 13 into 10 power minus 15. There is dash 10 power 6 volt. So so as you know that nucleus can be assumed to be uniform charge, uniformly charged sphere. So therefore, the potential at the center V, that will be equal to KQ by R. KQ by R is equal to K is 4 pi 1 by 4 pi epsilon naught into R. So Q, that is the net charge, that is the charge of the proton, which is 50 protons are there. So 50 into charge of one proton, that is 1.6 into 10 power minus 19 coulomb. The 50 into the Q is equal to N times it is Z in Z times UP. So Z, that is 50 into UP. UP is 1.6. From 60 to 10 power minus 19 coulomb by 4 pi 1 by 4 fraction naught is 9 to 10 power 9 pi R. R is 9 to 10 power minus 15. So this much volts. But this will be 9 and 9 will get cancelled. So then this will be, this is 100 by 2, which is 10 power 2 into 1.6 divided by 2 into 10 power minus 19 plus 9, that is minus 10 plus 15. This much volts. This will be equal to 0.8 to 10 power 5 plus 2, that is 10 power 7 volts. That is, I can say 8 into 10 power 6 volts. Therefore, here 8 is the answer. And here is told thin metallic wire, a thin metallic wire, having area of cross section, P, that is 10 power minus 4 meter square, is used to make a ring of radius 30 centimeter. So it is being curved to form a ring. Therefore, the radius of the ring is 30 centimeter. And it is told a positive charge 2 pi coulomb. The positive charge is 2 pi coulomb is uniformly distributed over the ring, while another positive charge 30 picocoulomb is kept at the center of the ring. Small charge Q is equal to 30 picocoulomb, 30 to 10 power minus 12 coulomb is kept at the center of the ring. The tension in the ring is, we have to find the tension in the ring, provided that the ring does not get deformed, negative the influence of gravity. So it is provided that the ring does not get deformed. Obviously, there will be some repulsion, repulsive force. So if you take an element, line element of the ring, which is of length dl. So here at the center, the angle formed is d theta. The tension in the ring, that will be T and T like this. So if let's say this will be d theta by 2. Now this one is d theta by 2. This would be 90 minus d theta by 2. This will be again d theta by 2. I can say the T, this is like this T is acting, so it is T cos d theta by 2, and this is also T cos d theta by 2. So that these two will get cancelled, and only here acting 2T sin d theta by 2. So that is equal to the repulsion. It is equal and opposite to the repulsion. So here at the center charge Q is placed, and here the net charge dq that will be equal to dq that is equal to lambda times dl. Lambda is the charge coordinate length, which is the net charge, which is 2 pi is q by 2 pi r. Is 2 pi by 2 pi r. So it is 1 by r coulomb per meter. So 1 by r coulomb per meter is the lambda. So 1 by r, that is 30 centimeters. So 30 by 100 meter. Since 1 centimeter is 1 by 100 meter. By 30 coulomb per meter. Cancels, so this 10 by 3 coulomb per meter. It's lambda. So dq is equal to lambda dl. dl we can say this is r d theta. So dq will be equal to lambda r d theta. So this is the this will be equal to the repulsive force, that is k into q into dq on q2 by r square. This is r square. So therefore, can say 2t, and since d theta is very small, d theta that is approximately 0. So sin d theta by 2, that is approximately equal to d theta by 2 only. That is 2t into d theta by 2, that is equal to k, that is q. 2 is 30 into 10 power minus 12 coulomb into dq. dq is lambda r d theta divided by, this is 1 by 4 by epsilon naught r square. R cancel. But here 1 r will remain. Now 2 will cancel out. D theta also will cancel out. So to find the tension in the string in the ring. So therefore T, that is equal to 30 into 10 power minus 12 to lambda divided by 4 pi epsilon naught. 4 pi epsilon naught r. Epsilon naught r. Therefore this will be 30 into 10 power minus 12 into lambda, that is 10 by 3. So 1 by R. R is equal to 30 by 100. It's 3 by 10. 1 by 3 by 10 into 1 by 4 plus 1 naught is 9 into 10 power 9. So this much will be the tension. This much Newton. Therefore, this will be 3 3 9. Is 30 into 10 power minus 12 plus 9 plus 2, which is 11. Since it is 30 to 10 power minus 1. So 1 by 10. So it is 3 Newton. So 3 Newton is the friction force. The ring. So the 3 Newton is answer. And here it's told that the electric field due to a short electric dipole at a distance at large distance r from center of the dipole on the equatorial plane varies with distance as. So one short dipole is there at a distance r in the equatorial plane. At a distance r on the equatorial plane, the electric field that is given as minus kp by r cubed. So now the magnitude of the electric field that is magnitude of the electric field will be kp by r cubed, where p is the dipole moment, where p is the dipole moment, which is q into 2a. It is equal to q into 2a by 4 pi epsilon naught into r cubed. So therefore, you can say that the magnitude of the electric field that will depend only on 1 by r cubed. So the magnitude of the electric field will vary as 1 by r cubed. So option D is the correct answer. When here is told a 10 microcoulomb charge is divided into two parts placed at 1 centimeter uh, distance so that the repulsive force in between them is maximum. Charges of the two parts are 10 microcoulomb charge divided into two parts and placed. Okay, so 10 microcoulomb charge. So here we have q charge and here I will have 10 minus q microcoulomb charge. So this is q microcoulomb and this is 10 minus q microcoulomb and placed at a distance r that is 1 centimeter apart so that the repulsive force between them is maximum. So the repulsive force between them is maximum. So the force that will be equal to magnitude of the repulsive force, that is k q1 into k0 by r squared. K1 into the r squared. So the force is equal to some constant. This k by r squared will be constant only, means it is q into 10 minus q by 4 pi epsilon of r squared. So this part is constant. So let's say f is equal to some f naught. You can say some constant c into constant into f naught q into 10 minus q. So this would be maximum. So it means F is a function of Q, which is F naught into Q into 10 minus Q. So for maximum force, we should have dF by dQ, or maximum force dF by dQ, that should be equal to 0. So therefore I can say d by dq of q to 10 minus q, that should be equal to 0. So it means it is 10q, so 10 minus 2q, that should be equal to 0. So q should be equal to 10 by 2, that is 5. So therefore q and 10 minus q, that should be same, that should be equal to 5 micro coulomb each. So each of the charges should be same. So option B is the correct answer. Here it is told two charges each of magnitude 0.01 coulomb two charges each of magnitude q, where q is 0.01 coulomb, is they are separated by a distance r, where r is 0.4 millimeter. 0.4 millimeter means it is 4 into 10 power minus 4 meter, constitute an electric dipole. So it means this should be minus q, this should be plus q. This should be minus q, this should be plus q. So it is a electric dipole. So I can take this length as L, suppose. So if the dipole is placed in an electric field of 10 dyne per coulomb, 10 dyne per coulomb, we know that one dyne, that is equal to 10 power minus 5 Newton. So it will be 10 power minus 4 Newton per coulomb, which makes an angle 30-degree angle with the electric field. So if this dipole is placed at an angle from electric field at an angle of 30-degree with the electric field. So this is the dipole, and this way we have the external electric field. And this is angle is 30-degree. Angle is 30-degree, making angle 30-degree with electric field. So then the magnitude of torque acting on the dipole is, so the torque, that is, we know that P cross E. So therefore now the magnitude of this torque, that will be equal to P is sine theta, where theta is the angle between the electric field and the dipole moment, and P, that is the dipole moment, which is equal to Q times L. Q times L separated by distance, so it is L. L is 0.4 millimeters. So it's 0.01 into 4 into 10 power minus 4 coulomb meter. So I can say this is 4 into 10 power minus 6 meter. 4 into 10 power minus 6 coulomb into the electric field, which is 10 power minus 4 into sine theta, sine 30. Since here theta is 30 degrees, so sine 30, that is half. Is 2 to the 4, so it is 2 into 10 power minus 10 Newton meter. 2 into 10 power minus 10 Newton meter. It is the magnitude of the torque acting on the dipole. So option D is the correct answer. Here it is told the assertion A, if an electric dipole of dipole moment is q into 2a, that is equal to 30 into 10 power minus 5 coulomb meter. So then it is enclosed by a closed surface. Here it is told that it's enclosed by a closed surface. The electric dipole is there, it is enclosed by a closed surface. The electric dipole moment is enclosed by a closed surface minus q plus q. Closed surface, the net flux coming out of the surface, will be zero only, since by the net charge enclosed within the sphere is zero, and since according to the Gauss law we know that the net electric flux through any closed surface is equal to the charge enclosed within the surface by epsilon naught. Now here, since the charge enclosed within the surface is zero only, so the net flux also will be zero. Then it is told electric dipole consists of two equal and opposite charges. So hence, since it contains two equal and opposite charges, so the net charge will be zero only. So the net flux also is zero. So I can say both A and R are true, and R is the correct explanation of it. So option D is the correct answer. And here it is told in a metallic conductor. In a metallic conductor, that the effect of an applied electric field, the free electrons of the conductor. So if some electric field is applied, then what will happen? The electrons will move in the direction opposite to the electric field. So here we will have excess of free electrons, and here we will have deficiency of electrons on the right side. So here we have deficiency of free electrons. So in a metallic electrons, under the effect of electric field, the free electrons of the conductor, so it will, in the direction of the electric field, as you know, the potential decreases. Potential decreases in the direction of the electric field. So on the right side, the potential is lower, and on the left side, the potential is higher. So the free electrons moving the from the spectrum. So they will move in cloud paths from lower potential to higher potential. They will not move with uniform velocity. They will move in curved paths from lower potential towards higher. So option D is the correct answer. Then it is told electric potential at a point P. Electric potential at a point P due to a point charge Q that is 5 into 10 power 5 into 10 power minus 9 coulomb. It is 50 volts. 50 volts. The electric potential at the point P. V that is equal to 50 volts, and that is equal to dq by R. The distance of the point P from the point charges. So as you know, electric potential due to a point charge that is given as kq by R. Electric potential due to a point charge that is kq by R. So this kq by R value that is equal to 50 volts. Then this R we have to find out, where R is the distance of this point P from this point charge. R is the distance of the point P from this point charge. So R will be equal to kq. K is 9 to 10 power 9 into Q, that is 50 volt, divided by Q is 5 into 10 power 5 into 10 power minus 9 by 50. Five into 10 power minus 9. So 10 power 9 and 10 power minus 9 cancel. 5 tens are 50, 5 ones are 5. So 9 by 10, R is 0.9 meter. So that is 90 centimeter. 90 centimeters. Option B is the correct answer. Here it is told graphical variation of electric field due to a uniformly charged insulating solid sphere of radius r. Graphical variation of the electric field due to a uniformly charged insulating solid sphere of radius r. With distance r from the center O is represented by uniformly charged insulating solid sphere. Okay. So here the net charge Q has been. So let's say the volume charge density, that is rho. So your volume charge density that is your dq by dv, that is equal to rho. Therefore, the net charge of this sphere Q, that is equal to rho into 4 by 3 pi RP. Now, therefore, how much is the electric field variation with RP? Find out. So if we take a point which is R is at some point inside the sphere where R is less than R. So then at this point, how much will the electric field? So electric field will be kq by R square only. If Q is the net charge enclosed inside this smaller sphere. So Q will be equal to rho into 4 by 3 pi small r cube divided by 4 pi epsilon naught into r square. Here r square will cancel. The r will come, and here pi will cancel. 4 pi will cancel. So it will come rho r by 3 epsilon naught. So it means here the electric field is directly proportional to R. For R less than R. R less than R. It will be a straight line. Initially, it will be a straight line. And for R more than or equal to R, the electric field will be equal to KQ by R square. So K into capital Q we should use since the entire charge will come. So the entire charge will be K, that is rho into 4 by 3 pi R cube into 4 by 3 pi R cube into 1 by 4 pi epsilon R square. 4 by 4 pi will cancel, so it is going to rho R cube by 3 epsilon naught R square. Therefore, the electric field that is equal to rho R cube by 3 epsilon naught R square. So it means that electric field is inversely proportional to R square for R greater than or equal to R. And the electric field that is equal to rho R by 3 epsilon naught for R less than R. So it means that the electric field is directly proportional to R for R less than R. So therefore I can say therefore option D is the correct answer. That so initially the electric field versus R will be a straight line which is passing to the origin, and at R equal to R the graph will change to 1 by R square radiation, which is like this, which is a curve path. So option D is the correct answer. And here it is told dipole comprises two charged particles of identical magnitude q and opposite in nature. Dipole consists of two charged particles of same magnitude but opposite in nature. The mass m of the positive charge particle, the mass m of the positive charge particle is half of the mass of the negative charge particle. So the negative charge particle has a mass twice of that of the positive charge particle. So its mass is 2m and its mass is m. Mass of the plus q charge is m and mass of the minus q charge is 2m. Then the two charges are separated. The two charges are separated by distance L. And if the dipole is placed in a uniform electric field E, this dipole is placed in a uniform electrical field in such a way that the dipole axis makes a very small angle with the electric field. So the electric field is like this, and this angle makes an angle theta with the electric field. So this angle theta is very small. Then here it is told the angular frequency of oscillations of the dipole when released is given by. So we know that the torque that will be equal to E is sine theta, that is equal to I omega square is equal to I alpha. what will be equal to I alpha, where I is the moment of inertia. Moment of inertia. P that is equal to Q into L. P is the dipole moment that is Q into L, and electric field E into sine theta. Since theta is very small, so sine theta I can say approximately equal to theta only. To theta that is equal to I. I is equal to actually moment of inertia we have to find out. So the axis of rotation, the axis of rotation is inwards. Since it is rotating above the electric field, it will rotate to and fro like this. So the axis is inwards. So I can say the moment of inertia that will be equal to mr square. So this length is L. So this is L by 2 and this is L by 2. This is the dipole displaced in commutations of the dipole measurement of is given by two charges, particles of in nature. So here actually it will oscillate about the center of mass. It will oscillate about the center of mass. So the net torque acting the couple. So towards the center only it will oscillate. So the point of inertia, which is equal to m into n by 2 whole square, mr square plus 2m into n by 2 whole square. That will be n square by 4 plus m square by 2. This will be 3 ml square by 4. This will be equal to 3 ml square by 4 into alpha. Now alpha that is equal to omega square theta. Say where omega is the angular frequency. Omega only we have to find out. So now therefore L and this L will cancel. So alpha will be equal to, this is actually L. Alpha is 4QE by 3ml to theta. 4QE by here actually they will rotate about their center of mass only. So the center of mass first we have to find out. Find out the center of mass first. Center of mass we have to find out. So we have center of mass will lie somewhere here, which is x will be equal to. So if we take this is the origin, then it will be 2m into 0 mx1 plus mx2 m into l into n by n plus m 3n. This is n by 3. So from here, this length will be n by 3 and this length will be 2n by 3. So therefore, we'll look at about the center of mass. So summation mr square. So here will be the axis of rotation. M into 2l by 3 whole square plus 2m into l by 3 whole square. Summation mr square. So it is 4ml square by 9 plus 2ml square by 9. Which is equal to 6ml square by 9. Just 236, 236, 6, 3, 9, so it is 2ml square by 3. So therefore, this will be 2ml square by 3. So therefore, we can say QE theta that is equal to 2ml by 3 into alpha. Therefore, alpha will be equal to 3QE by 2ml into theta. So therefore, omega square that is equal to 3QE by 2ml. So therefore, omega will be square root of this, square root of 3QE by 2ml. So option A is the correct answer. So it is the required angular frequency of oscillations of this type of field. Here it is told for a uniformly charged thin spherical shell, electric potential V radially away from the center O. For a uniformly charged thin spherical shell, for a uniformly charged thin spherical shell, the electric potential V radially away from the center of the shell. Charged thin spherical shell, the electric potential V radially away from the center of the shell. Radially away from the center of the shell can be represented as. So it is a thin spherical shell. So net charge Q is distributed uniformly on the surface. So inside V that will be equal to KQ by R for R less than or equal to R. Hence why electric potential at the surface will be same as the electric potential inside the sphere. And for outside the sphere, we will be able to KQ by R or R more than R. So therefore, for R less than or equal to R, the V is constant, and then for R more than R, it will decrease uniformly. V versus R. So therefore, A is the correct answer. Then it is told let sigma be the uniform surface charge density of two infinite thin plane sheets. Sigma is the uniform surface charge density of two infinite thin plane sheets as shown when the electric fields in region 1, 2, and 3 are. So the electric field in the region 1 that will be here, there will be repulsion, here also there will be repulsion. So it will be sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So sigma by epsilon naught. And in the region 2, here there is repulsion, here there is repulsion, so they will cancel. Since why they will apply the same electric field, and in region 3, that is okay. Region 3, that will be again E2, sorry, E3, that is equal to sigma by epsilon naught. And 0 for this plate also there is repulsion, this plate also there is repulsion. So E1 and E3, that will be sigma by epsilon naught n cap. For E1, that will be negative, obviously, since it is towards the left. So I can say minus sigma by epsilon naught n cap. And E3, that is sigma by epsilon naught n cap. And E2, that will be 0. Option C is the correct answer. Here it is told, consider a group of positive charges. Which of the following statements is correct? Net potential of the system cannot be zero at a point, but net electric field can be zero at that point. Where it is told, now for a group of positive charges Q1, Q2, Q3, Q4, etc., the net potential of the system cannot be zero at a point, but net electric field can be zero at a point. So net, yeah, so V net can't be zero, but net electric field can be zero also. Can be zero also. Net potential of the system at a point can be zero, but net electric field can't be zero at that point, which is wrong. Both the net potential and the net electric field cannot be zero at a point. So both the net potential and the net field can be zero at a point, but the net electric net potential can't be zero. Since y can't be zero, since y v net, that will be equal to v for Q1, that will be equal to KQ1 by R1 plus KQ2 by R2. Now, since all we have to add, so when we are adding, then it can't be zero. Since why if some charges are negative charge, then only some of them can get cancelled. But here all are having positive charges on. So the net potential can't be zero in this case. So option A is the correct answer. And it is told which of the following correctly represents the variation of electric potential V of a charged spherical conductor of radius r with radial distance r from the center. So V for a charged spherical conductor, that will be equal to KQ by R, which is constant at for r less than r, or r less than equal to r, and V will be equal to KQ by R for r more than r. That means for r less than or equal to r, the potential is constant, but for r more than r, the potential will vary as 1 by r. So it will gradually decrease with r. So option D is the correct answer. Here it is told that a point source of 100 watt emits light with 5% efficiency. At a distance of 5 meters from the source, the intensity produced by the electric field component is. A point source of 100 watt emits light with 5% efficiency. At a distance of 5 meters from the source, the intensity produced by the electric field component is. Distance of 5 meter from the source. Intensity produced by the electric field component is. The intensity produced by the light. So 5% efficiency. So it means the intensity that is emitted. Intensity emitted by the source, that will be equal to 5% of the 100 watt. That is equal to 5 watt. Now, at a distance of 5 meter from the source, intensity produced by the electric field component, that is be equal to I will be equal to this power by area. So 5 by, so intensity emitted by the electric field component, that will be equal to 5 by 2 watt, and area here. So the intensity will vary as 1 by r square. The intensity is 4 by r square. So the intensity, the we know that intensity is power by area. The power by area is intensity. So the power that is emitted, that is equal to intensity, that is 5 by 2 into area. So intensity at uh, a distance d from the source, at a distance d from the source, that the source that will be given as I naught by 4 pi d square. So I naught, that is the intensity emitted by the electric field. So that is 5 by 2 naught divided by 4 pi. Four pi into 5. The distance d is 5 meters, so d square, so 5 square. So 25 4 is 100. So it is 5 by 200 pi. Watt per meter square. So 200 watt per meter square. So it is power by area. Area is 4 pi. The power emitted is 5 watt, the source, and the power emitted by the electric field. The electric field is half of this, that is 5 by 2 watt. The intensity is 5 by 4 pi, 5 by 2 4 pi t square. So 5 4s are 20, so it is 1 by 40 pi watt per meter square. 1 by 40. So option A is the correct answer. So here it is told, as shown in the figure, a point charge Q is placed at the center of a conducting spherical shell of inner radius A and outer radius B. The electric field due to charge Q in three different regions. 1, 2, and 3 is given by. So this charge Q will induce a negative charge minus Q in the inner surface of the shell. So on the outer surface of the shell, one equal positive charge Q will be induced, and it will be uniformly distributed. It will be uniformly distributed throughout the surface of the shell. So I can say that electric field in the region 1, field in the region 1 we have to find. So first we can find electric field the region 3, E3, that will be equal to the outer surface, so that is KQ by R square. So R is D square, KQ by D square. Electric field in the region 2, that will be 0 only, since we know that a conductor is an equipotential body. So electric field inside the region of the shell, that will be 0 only. E2 will be 0, and E1, that will be how much? So E1, that will be somewhat that will be obviously KQ by region 3, that will be equal to KQ by R square. This is for R more than B. And here it will be KQ by R, where R is less than A. KQ by R square, where R is less than A. Since why for the outer part, the electric field that is so inside the region 1, there will be electric field due to the first charge Q, the small point charge Q1. Since if we apply the Gauss law, then the charge enclosed in the region 1, that is Q, so there will be electric field in the region 1. And if we apply Gauss law in the region 2, then we see that the net charge enclosed is 0 only in the region 2. So there is no electric field in the region 2. And also if we apply the Gauss law for the region 3, then we also see that the charge enclosed, that is equal to Q. So obviously there will be some electric field in the region 3. So E1, that will not be 0, E3 also will not be 0, but E2 will be 0. Option C is the option. Here it is told electric field in a certain region is given by E vector, that is A by x square I cap plus B by y square j cap. The SI unit of A and B are. So obviously A by x square and B by y cube. So x and y, obviously they will be units of length only. They will have units of length only. So now the unit of A by x square, that the unit of A by x square, that will be same as that of the unit of the electric field. Therefore, the unit of K, that will be same as the unit of electric field into the length square. So unit of electric field, as we know, the SI unit of electric field is Newton per coulomb. So this will be Newton per coulomb into meter square. So A will be the unit of A, the SI unit of A. So the SI unit of A is Newton meter square per coulomb. Similarly, the unit of E by Y cube is same as that of the electric field. So therefore, the unit of V that is same as the unit of electric field into Y cube means that the unit of electric field is Newton per coulomb into electric field. Therefore, the SI unit of B that is given as Newton meter cube per coulomb. Option B is the correct answer. Oh, sorry. Is asked to find the SI unit of A. The SI unit of A is Newton meter square per coulomb, and unit of B is Newton meter cube per coulomb. So option B is the answer. So hope all of you understood all these solutions of the previous year questions of JEE Mains exam. Still any doubts if you have, please write that in the comments. We shall obviously clarify them in the subsequent videos. Still, uh, any any doubts you have, please write that in the comments, and please install our Sapience education application also, where we shall upload some important previous year questions, which shall be obviously helpful for your exam. So thank you, everyone. Bye. Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter Electrostatics. So any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them in the subsequent videos. And in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments. So that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that two identical charged spheres are suspended by strings of equal length. The strings make an angle of angle theta with each other. So here it's told that two strings are there. They make an angle theta with respect to each other. This angle is theta. The lengths are same. When suspended in, okay, so they are having charged spheres. They are having some charged, so they are identical charged spheres. So it is, so they have charge q and their size is also same, means their radius is also same. When suspended in water, the angle remains the same. If density of the material of the sphere, density is also same, density rho, that is equal to 1.5 gram per centimeter cube. Gram per cc means cubic centimeter, so it is centimeter cube. The dielectric constant of the water will be, so inside water also the angle remains the same. So let's say this will be theta by 2, this will be also theta by 2. So then we can say that in air this is mg. This will be the electric field, which is kq1 q2 q2 by r square is r square. Here r, this is r, eq square by r square. So r is actually twice of, this is L sin theta, twice of L sin theta by 2, 2L sin theta by 2. And then mg, the mass, we can write it as the density into 4 by 3 pi r cube, where r is the
distance in between the two spheres, and capital R is the radius of each sphere. So now this angle is remaining the same. So therefore I can say this is the tension force is T sine, this is T cos theta by 2, this is T cos theta by 2, this will be T sine theta by 2. So I can say T sine theta by 2, that is equal to KQ square by R square, and T cos theta by 2, that is equal to mg. Mg, it is 4 rho by 3 pi R cube into G. So therefore tan theta is coming, therefore this is Q square by 4 pi epsilon naught R square by 4 rho by 3 pi R cube into G, means it is mg. And when it is kept in water, so in water also the angle is remaining the same, but the tension force may change. So I can say T dash sine theta by 2, that will be equal to, okay, here we can write. So in water, so these are happening in the air when the two spheres are kept in air. And in water also the angle is remaining the same. So in water I can say T dash sine theta by 2, that will be equal to KQ, which is Q square by 4 pi epsilon naught into the dielectric constant is asked, which is epsilon r. Epsilon r we have to find out. Epsilon naught into epsilon r into r square, where r will be equal to 2l sine theta by 2 only. And T dash cos theta by 2, that is equal to mg. T dash cos theta by 2, that will not be equal to mg. Here there will be an upthrust will act, that is mg, and there is v rho g, which is 4 by 3 pi r cube v into the density of water, that is 1 gram per centimeter cube. Density of water, let's call it as sigma into g. So T cos theta, that will be mg minus, means 4 by 3 pi r cube rho into g, mg minus 4 by 3 pi r cube into sigma into g, that is equal to 4 by 3 pi r cube into rho minus sigma into g. This is T dash cos theta by 2. So here also tan theta by 2, that will come this by this, that is equal to Q square by 4 pi epsilon naught epsilon r into r square divided by 4 by 3 pi r cube into g, that into rho minus sigma. And that is also same as this Q square by 4 pi epsilon naught r square divided by 4 by 3 pi r cube rho into g. So it means now we can say Q square will cancel, 4 pi epsilon naught r square, that will cancel, 4 by 3 pi r cube, 4 by 3 pi r cube g, that will cancel. So this we can write, this will be 1 by epsilon r divided by rho minus sigma, that is equal to 1 by rho. Means I can say rho by epsilon r, that will be equal to rho minus sigma. It means rho minus sigma, or I can say that epsilon r, that will be equal to rho by rho minus sigma. Okay. Rho by rho minus sigma. So therefore this will be rho is the density of the material of the sphere, which is 1.5 gram per centimeter cube by 1.5 minus 1. The density of water is 1 gram per centimeter cube. So it is 1.5 by 0.5, which is equal to 3. So I 3 is a 15. So epsilon r, the dielectric constant, is equal to 3. So 3 is the answer. And here it is told the distance between charges plus q and minus q, that is 2L. The distance in between charges plus q and minus q is 2L, and between plus 2q and minus 2q, that is 4L. So this length is 4L. This length is 4L. Yeah. So now it means this length will be L and this length also will be L. The electrostatic potential at point P at a distance r from center O is, at a distance r from center O, the electrostatic potential V at this point r, that is equal to minus alpha into QL by r square into 10 power 9 volt. And the value of alpha will be how much? And here it is told we can take 1 by 4 pi epsilon naught value as 9 into 10 power 9 Newton meter square per coulomb square. So now this is 60 degree. Therefore, we can say electrostatic potential so here we can assume that R is much more than L, then these two will act as a point dipole. So there are 2 point dipoles. So V at the point R we know that is equal to Kp cos theta by R square. Kp dot. Okay, so here angle theta, that is 60 degree. So V at R, that will be equal to V1 plus V2, means the electric potential due to the first dipole and the second dipole. So the first dipole P, that is P1, that is like this. So P1 vector, that is equal to, I can say, let's say I tell this is the x-axis and let's say this is the y-axis. So then I can say P1 vector, that is equal to q into 2L, q into 2L into I cap, and P2 vector, that is from minus 2q towards plus 2q. So this is 2q into 4L into minus I cap. And R vector, R cap. So actually it is Kp dot Kp vector dot R cap by R square, which is P vector dot R cap by 4 pi epsilon naught into R square. So now here R cap, which is the unit vector along the radius, unit vector along the position vector of point P, the unit vector along the position vector of point P, which is OP cap. So that will be equal to cos theta I, cos 60 I cap, cos 60 I cap plus sin 60 j cap, which is 1 by 2 I cap plus root 3 by 2 j cap, which is equal to 1 plus, okay. So I cap plus root 3 j cap by 2. This is R cap. Now, therefore, V at the point R, that will be equal to V1 at the point R plus V2 at the point R. Means V1, I am saying it is the electrostatic potential at the point P due to the dipole P1, and V2 is the potential at the point P due to the dipole P2. where P1 is Q into 2L I cap and P2 is 2Q into 4L minus I cap. So P1 is 2QL I cap and P2 is 8QL minus I cap. So now, therefore, now V1 of R, that will be equal to P1 vector dot R cap by 4 pi epsilon naught into R square. So this will be equal to P1, that is 2QL I cap dot with I cap plus root 3 J cap by 2 by 4 pi epsilon naught R square. So this will be, so I cap dot I cap is 1. So it is QL and I cap dot J cap is 0 obviously, and I cap dot I cap is 1. So therefore 2QL into half, that is QL by 4 pi epsilon naught R square. And similarly V2 of R, that is the electrostatic potential at point P due to the dipole P2. So this will be P2 vector dot R cap by 4 pi epsilon naught R square. So this will be P2, that is 8QL into minus I cap dot product with I cap plus root 3 J cap by 2. 3 J cap by 2 by 4 pi epsilon naught R square. Epsilon naught R square. So this will be minus, says minus 8QL into half divided by 4 pi epsilon naught R square. So this will be 2 4 is 8. So this will be minus 4QL by 4 pi epsilon naught R square. So therefore the net electrostatic potential at the point R due to the dipole P1 and P2, that will be equal to QL by 4 pi epsilon naught R square minus 4QL by 4 pi epsilon naught R square. So this will be equal to minus 3QL by 4 pi epsilon naught into R square. So this will be minus QL by minus 3QL by R square into 9 into 10 power 9. This much volts. This much volts. So this will be minus 3 9s are 27 minus 27 into QL by R square into 10 power 9 volts. So therefore, and it is told it is minus alpha into QL by R square into 10 power 9 volts. So therefore the value of alpha is 27. Alpha value is 27. And here it is told two identical charged spheres are suspended by strings of equal lengths. The strings make an angle of 37° with each other. Two identical charged spheres, so their charge is also q and their radius is also same and their density is also same, density, that is rho, suppose, and they make an angle of 37° theta. This is theta, which is 37° with each other when suspended in a liquid of density 0.7 gram per centimeter cube. The angle remains the same. The if density of the material of the sphere is 1.4 gram per centimeter cube, so here rho is given 1.4 gram per centimeter cube, and the density of the liquid sigma in which it is kept, that is 0.7 gram per centimeter cube. The dielectric constant of the liquid, epsilon r, that has been asked. Epsilon r, it is the relative permittivity, which is also called dielectric constant, and tan 37 value, that is given as 3/4. So now the length of the string, that is L, same length has been told. So, and here, so we can take, suppose in the first case it is kept in air. So here the mg is acting downwards, and here aq square means q square by 4 pi epsilon naught into r square is the electrostatic force, and this is the tension force. So this angle will be theta by 2. So this angle, this will be t sine theta by 2, and this way it will be t cos theta by 2. Since this angle is theta by 2, then this angle will be also theta by 2. So therefore I can say t sine theta by 2, that is equal to q square by 4 pi epsilon naught r square, where r square, small r square, it is the uh, distance in between the two spheres. This is r. So r value we can say that is actually equal to 2l sine theta by 2. 2 into L sine theta by 2, means R by 2 is L sine theta by 2. So this is remaining the same only, and T cos theta by 2, that will be equal to mg, that is v rho g, 4 by 3 pi r cube into rho into g. And similarly, when it is kept in water, then the on the sphere the tension force will change, that is suppose T dash, but the angle is remaining the same, it has been told. So T dash sine theta by 2, that will be equal to q square by 4 pi epsilon naught into epsilon r into r square. R will remain the same, but here mg is acting downwards, but upwards the upthrust is acting, which is v sigma g, and here we have T dash cos theta by 2 also. So therefore we can say that T dash sine theta by 2, that is equal to q square by 4 pi epsilon naught into epsilon r into r square. Epsilon r value has been asked, we have to find that. And T dash cos theta by 2, that will be equal to mg minus v rho g. So that is 4 by 3 pi r cube into rho g minus 4 by 3 pi r cube into sigma g. So therefore in air we can say, if we divide these two equations, then we will get tan theta by 2, that is equal to q square by 4 pi epsilon naught into r square divided by 4 by 3 pi r cube into rho into g. And in the liquid, in the given liquid, it is not in water, it is in the given liquid. In the liquid we have tan theta by 2, that will be equal to q square by 4 pi epsilon naught into epsilon r into r square divided by 4 by 3 pi r cube, 4 by 3 pi r cube into sigma into g, by 3 pi r cube into sigma into g. So these two are same only. So we have to, no, it is not sigma g, it is rho minus sigma into g. Is rho minus sigma into g, rho minus sigma into g. Okay. So these two are same. So I can say q square by 4 pi epsilon naught into epsilon naught into r square into 1 by 4 by 3 pi r cube into rho g, that is equal to q square by 4 pi epsilon naught into epsilon r into r square into 1 by 4 by 3 pi r cube into rho minus sigma into g. So if you cancel q square will cancel, 4 pi epsilon naught r square, 4 pi epsilon naught r square will cancel, 4 by 3 pi r cube, 4 by 3 pi r cube will cancel, g and g will cancel. So from here we get 1 by rho, that is equal to 1 by epsilon r into rho minus sigma. So therefore epsilon r, that is equal to epsilon r into rho minus sigma, that will be equal to rho. So therefore epsilon r, that will be equal to rho by rho minus sigma. Now rho is the density of the material of the sphere, that is 1.4 gram per centimeter cube. So 1.4 minus sigma is 0.7, which is the density of the liquid, 0.7. So this is 1.4 by to the 14, so 0.7, 7 to the 14. So epsilon r is equal to 2. So therefore the value of the dielectric constant of the liquid is 2. So 2 is the answer. And here it is told an electron is moving under the influence of an electric field. So the electric field is in the opposite direction. Electric field of a uniformly charged infinite plane sheet. So the infinite plane sheet is here, which is like this. So it is having surface charge density plus sigma. So the electric field is equal to sigma by 2 epsilon naught. The electron at t equal to 0 is at a distance of 1 meter from the plane sheet S. So at t equal to 0, and has a speed of 1 meter per second. So u is 1 meter per second. The maximum value of sigma, if the electron strikes it at as at t equal to 1 second is. So what should be the maximum value of sigma so that it hits at t equal to 1 second, so that it hits the sheet, or I can say it strikes the plane sheet S at t equal to 1 second is that we have to find out. So 1 meter it will cover in 1 second. So here the force that is acting on the electron, that is the charge of the electron into E, that is sigma E by 2 epsilon naught. So therefore the acceleration of the electron, that is force by mass, so that is sigma E by 2 m epsilon naught. So this is the acceleration which is constant. So when there is constant acceleration, I can say it is uniformly accelerated. It is uniformly accelerated. So therefore we can say S is equal to ut plus half at square. S equal to ut plus half at square. Not S, we can tell it as S dash, suppose. Or let's say we call it as uh, ut plus half at square will be the net uh, uh, displacement of the electron. So the displacement of the electron is 1 meter, that is equal to ut. U is 1 into time is also 1. In time 1 second only, the displacement should be 1 meter, it has been told. So plus half at square plus half a is sigma e by 2 m epsilon naught into t square, which is 1. Distance of 1 meter. Distance 1 meter from S. So here it is told that the maximum value of sigma, it means that sigma should be less than or equal to alpha m epsilon naught by E, coulomb per meter square. So then the value of alpha we have to find out. So from here we can say, if we cancel a 1 and 1, then we can say sigma E by 4 m epsilon naught, that should be equal to 0. So it means sigma should be equal to 0 into m epsilon naught by E. So sigma should be, so alpha should be 0. So here So here, okay, so here the force is acting, electric field is like this. Speed of 1 meter per second. This can be away from the charge also, means away from the sheet also. It can be like this 1 meter per second. Then it will get retardation from here. So I can say this u, I should take it as -1 then. -1 meter per second, and acceleration will be plus, since it is the acceleration is acting towards the right. So I can say minus of this, so this won't cancel. So therefore I can say this part is wrong then. Ut plus half t square is the displacement. So u is -1 into t plus half into a, that is sigma e by 2m epsilon naught into t square. T is 1 is equal to 1, the displacement. So I can say that sigma e by 4m epsilon naught, that is equal to 1 plus 1, that is 2. So therefore sigma, that is equal to 8m epsilon naught by e. So therefore, which is equal to alpha m epsilon naught by e. So therefore the value of alpha is 8. So the value of alpha will be 8. So it means that the initial velocity of the electron is away from the plane sheet. So it is not initially moving towards the plane sheet, it is initially moving away from the plane sheet. So here it is told that the charges of -4 microcoulomb and +4 microcoulomb are placed at the point A, that is 1, 0,4 meters, and point B, that is 2, -1, 5 meter. Here +4 microcoulomb is kept, and no, here -4 is kept, and here +4 microcoulomb is kept. Let's say we call this as -q, this is +q, and located in an electric field which is 0.2 I cap volt per centimeter. The magnitude of the torque acting on the dipole, torque acting, that is equal to 8 root alpha plus 8 root alpha into 10 power -5 Newton meter. So then alpha value will be how much? So the magnitude of the torque has been told. So we know that the magnitude of the torque acting on a dipole which is placed in an uniform electric field, that is equal to P cross E. Torque equal to P cross E, which is, so the magnitude of the torque, we can find it, which is magnitude of P cross E. So now P vector, that is equal to Q into the vector from negative charge towards the positive charge, which is the vector AB. Q into AB vector, that we have to find. So now therefore AB vector, that is obviously equal to OA vector minus, no, OB vector minus OA vector. So OB vector is 2 I cap minus J cap plus 5K cap minus OA vector, that is I cap plus 4K cap. I cap plus 4K cap meters. So this will be I cap minus J cap, then plus K cap meters. AB vector is this. So, and Q, that is equal to 4 micro coulomb, which is 4 into 10 power minus 6 coulomb. So therefore the dipole moment vector, that is equal to 4 into 10 power minus 6 into I cap minus J cap plus K cap coulomb meter. So coulomb meter is the SI unit of dipole moment. Then electric field is 0.2 I cap volt per centimeter. So now, therefore, the electric field that is 0.2 I cap, 0.2 I cap volt per centimeter. So 1 centimeter is 10 power minus 2 meter. 1 centimeter is 10 power minus 2 meter. So this I can say 0.2 means 2 into 10 power minus 1 into 10 power 2 volt per meter I cap. So this will be 20 volt per meter I cap. So this is the electric field in the SI unit. So now therefore the torque will be equal to P cross E. P cross E. So this will be equal to P, that is 4 into 10 power minus 6 into I cap minus j cap plus k cap. I cap minus j cap plus k cap in cross product with 20 I cap, and this will come in torque Newton meter. P cross E. Okay. So this will be 4 to the 8, 80 into 10 power minus 6 into, this is I cap cross I cap, then minus j cap cross I cap plus k cap cross I cap. Now we know that I cross I, that will be 0 only, 0 vector, and j cross I, so we know that I j k. So I cross j is k, so j cross I is minus k, j cross k is I, k cross I is j. So therefore this will be this much Newton meter, so it will be 80 into 10 power minus 6 into, this will be I cross I is 0 vector minus this is j cross I, that is minus k cap plus k cross I, that is j Newton meter. So this will be 80 into 10 power minus 6 into, this will be j cap plus k cap Newton meter. So therefore this is the torque acting. So the magnitude of this torque, that will be 80 into 10 power minus 6 into square root of 1 square plus 1 square, that will be root 2. So 80 root 2 into 10 power minus 6 Newton meter. 80 root 2. So this I can write 8 root 2 into 10 power minus 5 Newton meter, and which is given as 8 root alpha into 10 power minus 5 Newton meter. So therefore the value of alpha is 2. Therefore the value of alpha will be 2. So alpha value is 2. So 2 is the answer.